everyone. From chapter 4 Combinatorics, I already discussed the basic of counting, permutation and combination, binomial coefficient and identities, pigeonhole principle, inclusion exclusion. Next I will discuss the recurrence relation. Before discussing recurrence relation definition, let's see some example that you can understand how we are forming the recurrence relation. Example 1, rabbit and the Fibonacci number. Consider this problem, which was originally posed by Leonardo Fijano, was known as the Fibonacci in the 13th century in his book Liber Abaci. A young pair of rabbit, one of each sex, means one is male, another is female, is placed on an island. A pair of rabbit does not breed until they are 2 months old. Okay, after 2 months means from 3 months they can breed, they can have their child. After they are 2 months old, each pair of rabbits can produce another pair each month as shown in the figure. I'll discuss the figure. Now we need to find the recurrence relation for the number of pair of rabbit on the island after n months, assuming that no rabbits ever die. So this is our figure. Here reproducing pair at least 2 months. Here is the young pair less than 2 months. Then first is month, producing pair, young pair and total pair. Okay. So initially this is let male 1, female 1. They both are month 1. Then here in month 2 they also cannot produce. After second month they can produce. Okay. So now in third month they both can produce. So here is male 1, female 1. They can produce male 2, female 2. Okay. In month 3 they can produce male 2, female 2. So here total pair equals to 2. One is parent pair and one is the child pair. Okay. Next in fourth month, male 1, female 1. They can produce male 3, female 3. Also male 2, female 2, which are in second month. Here they are in first month, here they are in second month. They still cannot produce. Next month they will produce. So here total 3 pair. One parent pair, 2 child pair. From the child, 1 pair is second month, 1 pair is first month. So total pair is 3. 1 parent, 2 child. Now in fifth month, so male 1, female 1. Now this male 2, female 2, they are in third month. So male 2, female 2, male 1, female 1. They can let produce male 4, female 4. Male 2, female 2, let they can produce male 5, female 5. Male 3, female 3. There are 5 pairs, right? And if we'll see 2 plus 3 equals to 5. Like in 6th month, it will be 3 plus 5 equals to 8. So in first month 1, second month 1, third month 1 plus 1, 2, fourth month 2 plus 1, 3, fifth month 3 plus 2, 5, sixth month 5 plus 3, 8. So that we can denote by f of n. N can be 1, 2, 3, any number. So f of 1 equals to 1, f of 2 equals to 1. These are the number of rabbit pair in first and second month. Then f of n equals to f of n minus 1 plus f of n minus 2. So it is addition of previous 2. So the number of pair of rabbit on the island after n month is given by the nth Fibonacci number, and this number sequence called as Fibonacci number. So 1, 1, 2, then 2 plus 1, 3, 2 plus 3, 5, 5 plus 3, 8, 8 plus 5, 13, 13 plus 8, it's 21, 21 plus 13, 34, like this it will continue. So this sequence called as Fibonacci sequence, and this is the recurrence relation for Fibonacci sequence. Let's see next example. Example 2, it is Tower of Hanoi. This is a popular puzzle of the late 19th century invented by the French mathematician called the Tower of Hanoi, and consists of 3 pegs mounted by the board together with a disc of different size. Initially, the discs are placed on the first peg in order of size, with the largest at the bottom and smallest at the top. And the rule is we'll move one at a time from one peg to another peg, as a disc never placed on top of the smaller disc. Okay, so above smaller disc we cannot keep the larger disc, above larger we can keep the smaller disc. And the goal of the puzzle is to have all discs on the third peg in order of size, with the largest at the bottom. So initially it will be like this. There are 3 pegs, peg 1, peg 2, peg 3, and in peg 1 there are some discs. At lowest there is the largest disc disk, at top there is the smaller disk, and we need to move one disk at a time, and we cannot keep larger disk above the smaller disk. First understand this problem, then you can easily find the recurrence relation for it. So here we have 3 disks and 3 peg. Our target is to move these 3 disks from first peg to third peg, right? So how will move? So first we'll move this to here, then the second one here, then the smallest one here. So first target 2 disks will move from first to second by using the third. So if there are n, then n minus 1 disk will move to second by using the third. Next we'll move this third disk from first to third, then we can move this to first, then second will come here, then first will come here, right? Total number of move equals to 7. Suppose we have 4 disks. How will move this disk from first peg to third peg? Let's solve it. So first target moving top 3 disks from first to second. So we'll move the largest disk from first to third. Then we can move the n minus 1 means 3 disks from second to third. And total number of move equals to 15. So how will solve it? First from the n disk from peg 1 we'll move n minus 1 disk from first to second by using the third. Then we'll move the largest disk from first to third peg. Then that n minus 1 disk from the second peg will move to third peg. Okay. So there are first, second, third. So first we'll move n minus 1 disk from first to second, and here last disk that will move from first to third, and after that we'll move second to third, that n minus 1 disk, and it will be sorted. We are doing hn minus 1 move from first to second, and then we are doing one move from first to third, then again we are doing hn minus 1 move from second to third. So what will be the recurrence relation? H of n will be 2hn minus 1 plus 1. 2hn minus 1 for first to second and second to third, and this one move is for the largest disk that we are moving from first peg to third peg. So we got the recurrence relation. Recurrence relation is h of n equals to 2 h of n minus 1 plus 1. Now in place of this h of n minus 1, we can write 2 h of n minus 2 plus 1. Now substitute here. After substitution, we'll get 2 of hn minus 2 plus 1. Before this 1 was there. Now multiply. So 2 multiplied 2, it's 2 square hn minus 2 plus 2 multiplied 1, 2 plus 1. Again, in place of this h of n minus 2, we can substitute, and like this, if it will continue, we'll get finally 2 power n minus 1 h of 1 plus 2 power n minus 2 plus 2 power n minus 3, like this 2 plus 1. And what is h of 1? H of 1 is how many movement we are doing. For one disk, we'll just do one movement. So h of 1 equals to 1, right? So 2 power n minus 1 plus 2 power n minus 2 plus 2 power n minus 3, like this 2 plus 1. So what is the value of this? We know this formula. It will be 2 power n minus 1. I already discussed for 3, 7 moves. For 4, there are 15 moves. So for 3, 2 power 3 minus 1. 2 power 3 is 8. 8 minus 1 is 7, right? For 4, 2 power 4, 16 minus 1. It's 15 move. Now for 10 disk, how many move will be there? 2 power 10 minus 1. 2 power 10 is 1024 minus 1. It's 1023. In today's lecture, I discussed Fibonacci sequence and Tower of Hanoi. In next lecture, I will discuss some more examples of recurrence relation. If this lecture is helpful for you, please like, share and subscribe. Thank you.